All right, so this is areas of a trapezoid, rhombus, and kite. This is 10.2. So we're going to cover the formulas for these two, do a couple of examples. So what we're looking at here is we have to recall that in a trapezoid, we have a couple of things that we need to label. So in a trapezoid, it says the height of a trapezoid is the perpendicular distance between its bases. So that's the reason why this dotted line is here, and you're going to want to add that, because once you see that this is a right angle here, that is the height of the trapezoid. In other words, if you're trying to find the height of a wall, you don't stand out in the middle of the room and measure the distance between you and the top of the wall. You actually just go straight up from the bottom of the wall to the wall, and that's what a perpendicular would be. That's why that is what our height is. So our height is labeled there. And then what we also have is, again, this is a height, so we're going to call that a height. Both of these are trapezoids. And then what a trapezoid is, recall, is we have two bases that are perpendicular, or that are parallel to each other. So this base and this base are parallel. This base and this base are parallel. And we're going to call this base 1, and we're going to call this base 2. And we put a little line on these to show that they are parallel. So you want to label that on your picture. So this is base 1. And it really doesn't matter which one you call base 1 and which one you call base 2, as long as you understand that they are two different bases. So once you have this information, our formula is just going to be area equals 1/2 times the height times base 1 plus base 2. And that's always the formula. So you need the height of the trapezoid, and then you need the base 1 and base 2. For a rhombus, all this is marked on, and you want to make sure you mark this accordingly. A rhombus, all four sides are equal to each other, and the diagonals, that's what we call these that are going through here. So I'm going to have this dotted line represent the line that goes through this. That is what we call diagonal 1. Okay, so we'll call that D sub 1. And then the other diagonal that's going horizontally across, that is called D sub 2. And what we need to understand is these diagonals of a rhombus will bisect one another, meaning this diagonal cuts this diagonal going horizontally into two equal parts, and this diagonal going horizontally cuts the vertical one into two equal parts. But we have diagonal 1 and we have diagonal 2. The same thing is true with the kite. You can see that the two adjacent sides are congruent on a kite. Okay, not all four sides are the same like on a rhombus, so it's a little bit different. And then we also know that this long diagonal will always bisect the short diagonal. And again, these are right angles here. So again, we're going to call this D1 and D2. Remember, the diagonals are what's cutting through the middle of the figure. It's not any of the edges. And the formula for the area here is just 1/2 times the length of diagonal 1 times the length of diagonal 2. Okay, so let's put this into practice on a couple of problems. So, obviously we can get multiple types of problems here, and we want to make sure that we can, work through these with a reasonable amount of easiness, but there are going to be some challenging problems. This first one is a very straightforward problem because everything that you need is given to you. So again, we always start by, okay, this is a trapezoid, so we start by writing out the formula. 1/2 times the height times B1 plus B2. And then we just plug in what we know. 1/2. Our H is 20, so we plug in 20. Our B1 is 12, and our B2 is 18. Okay, and then we multiply this out, put it in a calculator, whatever it takes, and you get area equals 300 inches squared. Okay, so make sure that you are labeling it. Remember, formula is 1 point, plugging in, 2nd point, answer, 3rd point, units, 4th point. Okay, so over here we have a rhombus. So let's look at the rhombus here. We're just going to go through these examples fairly quickly. So what we have here is a rhombus. So what we want to do here, and this is a little bit more difficult because if we want to figure out what our diagonals are, remember, the first thing is we're going to write out our formula, 1/2 D1 times D2. So we need diagonal 1 and we need diagonal 2. Well, we know the diagonals bisect each other, so if this one right here is 9, then we know that this is going to have to be 9 as well. So I can tell you that diagonal 1 is going to be equal to 18. So that's our first step, is figuring out that that's 18. The problem, or the difficult portion, is figuring out what is this diagonal. And it's not 15, and that's the big mistake that many of you will make, is you just assume that because that's given to you, that that must be the other diagonal. But no, in reality, what we need to do is, we know this is a right triangle. So what we need to do is we've got to figure out what this missing side of this right triangle is, and we're going to use the Pythagorean theorem to do this. Okay, so what this is going to look like is, this is the hypotenuse, so we have 15 squared equals 9 squared plus, and then we have our unknown side, and you can call that whatever you want, so we're going to call it x squared. So 15 squared is 225, and you've all done the Pythagorean theorem before, so you should have experience doing this. So 81 plus x squared minus 81 from both sides, you get 144 equals x squared. Take the square root of both sides, and you get x equals 12. So that means that this diagonal right here is 12, or this part right here is 12, which means if we want the other diagonal, we know that's also 12. So 12 plus 12 is 24. So diagonal 2 is going to be 24. So now we can use our formula. A equals 1/2 times 18 times 24. Okay? Plug that in, and you're going to get area equals 216 yards squared. So very important that you take these step by step. Okay? If you're missing something, then you have to use some type of method to find it, and usually the Pythagorean theorem is what's going to be used. Okay? All right, so down on this one, I want you to do this one on your own. Okay? Do this one on your own, see if you can come up with it. Remember, if we want the area of the entire place that you can swim, that means the blue portion here. So keep in mind, if I wanted the area of just the blue portion, it will be the area of the entire rectangle subtracting the area of the trapezoid. So I'll start that for you. Area of blue will equal the area of the rectangle, that's A sub r, minus area of the trapezoid. So try and do that on your own. Hit play when you're ready so you can see if you get the answer right. So hit pause and take a minute to do that. Okay, so looking at this, we have our area of our rectangle is base times height, so that was 2100. The area of the trapezoid, 1/2 height, base 1 plus base 2, is 72. And now we subtract. We subtract our area of our rectangle minus the area of the trapezoid, and that will give us what's left over. You should have gotten 2,028 feet squared. Okay, on the last one, again, I want you to do this one on your own, but again, pay attention. You are given the area, and you want to figure out what the other diagonal is. So make sure you use your formula to do that of a kite. This one should be pretty easy for you too. Use the formula, plug in what you know, and then continue from there. Again, hit play when you are ready. Okay, so you should have gotten 14 inches for this. Again, you have 1/2 D1, D2. You plug in what you know, which is the 1/2, the 6, and the 42. 1/2 times 6 is 3. Divide by 3 on both sides, you get 14. Don't forget to label it as inches. It's one-dimensional now, so there's no inches squared. Remember, area is inches squared. Distance or length is just a single unit, inches or feet or whatever. Okay, so that's it for this section. Again, if an Edmodo quiz has been assigned, make sure you take that and bring questions and ready to work tomorrow. See you then.